Hello, welcome to Lab 9, asynchronous disk reads. So the point of this question is just to determine the possible order of events. So as a quick recap, when we request a disk read, at some point in the future, when the disk read actually finishes, it will call the interrupt service routine with the result. And so it calls the callback, and so let's just determine the possible order of events that could happen. So let's say we are in run, and run, we first print f, and then we call disk read. So in disk read, we set the callback function to foo, and then we call print d. So d will print, and at this point, we call request disk read. So this hands it off to the disk controller, and at some point in the future, it will call the interrupt service routine when it actually finishes the read. So the question is, what goes on in the middle here, and what goes on after? So we don't know exactly when the disk read will finish. So let's just look at a few different possibilities. So it could be that our disk is extremely fast for some reason, that it's like even faster than our processor going to the next instruction. So let's say the interrupt happens right here. So what would this print? So when it calls the ISR, it just prints A, C, because we call the callback function, which prints C, and then B. So, and then we finish with the interrupt, and we just go on to the next line. So then we print E, and then this function returns, and we print G. So that is one ordering. So what else could happen? Let's say our disk is a little bit more slow this time, and it prints. It interrupts after the E is printed. So let's say it interrupts right here. Okay. So what happens now is it goes on as normal, the same as previous. So we print F and then D, and then we request a disk read. And then it prints E. And then our ISR happens. And in the ISR, it prints A, and then C, and then B. So then we just this function returns, and then we print G. So what is another possibility? So let's say our disk is even more slow this time, and it interrupts sometime after G happens. So again, it's FD, and then we request the disk read. Then we just go on to the next line. This prints E, and then this function returns, and we print G, and then finally the disk read finishes and it interrupts. So the interrupt service routine is called, and then we print AC. All right. So we have this asynchronous function that calculates the nth prime number, and it will call the callback function with the requested prime number when it's actually ready. So the point here is that calculating the nth prime probably take some time. The comparison would be like if you enter a search term into Amazon, the whole browser should not just freeze up. Like it should just move on to the rest of the code that controls the browser, and when your search result is actually ready, it will interrupt and uh, uh, get the search result. Right? So nth prime takes some time, which you just move on to the rest of the program while waiting for that result. So it should not be just spin waiting or polling until the result is ready. So whether you calculate the nth prime yourself, which you probably should never do, since like humans have calculated prime numbers to uh, uh, to millions of digits, right? So if you want a large prime number, just so you'll either like call some web API that retrieves it from some database, or you're reading it from a file on a disk. So I think the strangest thing about this question is that when the result is ready, it'll interrupt and then it'll call the callback function with the value of the requested prime number as an argument. So if you've never seen asynchronous calls before, I think this is pretty strange. If you've seen it before, it would probably be in the context of JavaScript. And JavaScript is a pretty big deal, right? Because that's just like any web related software engineering. So if you plan to work with JavaScript or some framework like React or whatever, then you'll know. And also ComSci 310. Let's code this up. So just ignore these two functions. This function represents what comes before, and this function represents the rest of the program. So we'll first make a call to nth prime 100, and the callback function will be, let's just call it handle 100. So when we actually have the result of the 100 prime number, it will call handle 100. So void handle 100 int result. Okay. So I have this fake interrupt service routine up here. So you could imagine that it does something like that. Right? So the 100th prime number is 541. So this kind of does something like callback, and it calls it with the result. Okay, or since our callback function is handle read, so you could imagine it doing something like handle 105 541 in pseudocode. All right, so our result here will be the 100th prime number. And let's just save this to a global variable. So int prime 100, and p100 equals result. And once we have the result of the 100th prime, let's just schedule the next thing. So nth prime 200, and the callback function, let's just call it handle 200. Okay. All right. So handle 200, and the result here will be the 200th prime. So we can just print out our product. So printf p100 times result. Right. So let's make this. Right. So yeah. So we could imagine that if we wanted the product of the 100th, the 200th, and the 300th prime, we might chain another one. Right? So this would be like prime nth prime 300, and then we'll call d200, and we'll save it. Okay, so so you see that this is kind of getting to some like extremely messy code. So you might have heard of this term. So this is called callback hell, where we chain callbacks, where this callback does another async request and the callback function does another callback function, right? So yeah, let's see a better way to do this. So let's say each call to nth prime takes like 1.5 seconds or whatever. So what is the runtime of this program? Well, let's bring it back to what it was before. All right. So make let's see, let's time this. So, lab 9. Okay. So yeah, so it's about so it's double the time of a single call. So this is just due to that our next call is not scheduled until the previous one finishes. So is there a better way to do this? So the time lag is really just between calling nth prime and when the result is actually ready and it interrupts and calls a callback. And so we could schedule both of these simultaneously so that the requests happen in parallel. So this approach, it should take about half the time as whatever time the previous one was. So instead here, we will change this to, so product equals 1, and we can just multiply into it. Product times equal result. And we'll do the same thing up here. So now the problem is, where should we print the result? Even though we schedule the 100th before the 200th prime number, there's no guarantee that the callback functions will happen in the order that you schedule them. Just that, like in a more realistic disk, there's no guarantee that there's some kind of randomness in your disk reads, right? Or if you're calling some web API, there's probably some kind of delay and randomness. So we don't know which one is going to print first. So whether handle 100 is called first or handle 200, we don't know. So if we just print it here, it might have the wrong product. It might just have been multiplied once. So we will have to check if product is, this is like one clunky way to do it. And we'll do the same thing for the other one. So if product is greater than result, that means it has already been multiplied before, right? So this approach, it should take about half the time as before. So make and time. Okay. There we go. So if we wanted the product of the 100th, the 200th, and the 300th prime numbers, we could do something like this. So this, instead of taking 3 times the amount of time for a single nth prime call, this should still just take pretty much the time for one call, right? Because we can schedule all of them at once. So we will, I think we can just change this to handle. We can just use this the same callback function. Okay. And let's add a flag called ready that just counts the number of times that we've called the callback function. So ready plus plus, and we'll only print it if all of our results are ready. and this should work unlike last time if you just ignore what I have here. Okay, so this should take still pretty much the same time. Oh no, what did I do wrong? Oh. Huh? Oh, I just didn't scroll down. Okay. Okay, never mind. Yeah, there you go.